Okay, let's start. Welcome to the workshop on dynamic algorithms, recent advances and applications. So I am Sayan Bhattacharya, and together with Thatchaphol Saranurak, I am co-organizing this workshop. And you might have seen that initially Danupan Nanankai was supposed to give the first talk, but unfortunately he couldn't be here. So as a replacement, Thatchaphol and I will now present a brief introduction to the workshop before the next tutorial talk begins. Good. So first we need to ask, what is the purpose of this workshop? And here I should start by emphasizing that the intended audience is both dynamic algorithms researchers and people working in other areas of TCS who are not necessarily familiar with dynamic algorithms. So we expect that both these groups of people will get something valuable out of attending this workshop. Now for the later group of people who are not necessarily familiar with dynamic algorithms, let me try to answer two obvious questions. One, what is a dynamic algorithm? And B, why should you care about it, even if you are not familiar with it? So to answer the first question, you can think of a dynamic algorithm as follows. Pick your favorite computational problem and take any algorithm for it. And suppose on a given input I, it comes up with an output O. Now consider the following setting. The input keeps changing by a sequence of updates, where each update changes the input by some small amount, delta I. And after each update, the algorithm now needs to return the new answer on the current input. So how do we deal with this setting? There is a naive answer to this question. Simply run the same static algorithm from scratch after every update on the current input. But in dynamic algorithms, we ask, can we do something significantly better than this naive solution? In particular, we refer to the time taken by the algorithm to handle an update as the update time. And what we are asking is, for any given fundamental problem in this dynamic setting, can we come up with algorithms whose update times are significantly faster than the running time from recomputing from scratch? And as you can see, not only is this a very natural setting to consider, you can ask this question in the context of any optimization problem. Okay. So this is answering the first question. As far as the second question is concerned, why should you care about dynamic algorithms? Let me try to give you three answers. The first one is, often it so happens that if you design efficient dynamic algorithm for one problem, you get faster static algorithm for some other problem. And to illustrate this, let me show you this screenshot. This is probably one of the very first celebrated papers in dynamic data structures by Slater and Tarjan. And as you can see, it came out in around 1982, 40 years back. You look at the abstract, and it just says, using this data structure, new fast algorithms are designed for the following. And bullet point 2 says, solving various network flow problems, including finding maximum flows, blocking flows, and acyclic flows. So if you are doing algorithms, I think I don't need to convince you that maximum flow is an important problem. And if you care about maximum flow, you should care about dynamic data structures. So this is from the early 80s. Now fast forward 40 years. Very recently, we had this breakthrough result, which gave almost linear time algorithm for exact max flow in directed graphs. The archive version was posted on April 26, very recent. And again, you look at the abstract, and just the abstract clarifies that we obtain our results using a new dynamic graph data structure. So there is something fundamental going on here, where we see that using fast dynamic algorithms, we obtain faster static algorithms for fundamental problems. So that's reason number one. Reason number two is It seems counterintuitive at first, but dynamic algorithms and data structures are finding applications in other areas of computer science as well. So for instance, there is one invited talk in this workshop which will explain recent applications of dynamic algorithms in areas such as machine learning. So if you care about machine learning, you should know about dynamic algorithms a bit. And finally, the third reason is that in recent years, we have seen an explosive growth of activities in this area, which has led to fascinating transfers of techniques between other areas of TCS. So just to name a few: expanders, differential privacy, vertex specification, and many others. We see techniques basically which were first introduced in some other area now finding applications in dynamic algorithms. And quite a lot of the invited talks and tutorial talks will be following this theme. So to summarize, the workshop will showcase recent exciting developments in this area, and I hope all of you will find it very interesting and enjoyable. And to tell you in a bit more details about what's going to come next in the workshop, now Thatchaphol will take over and just give you a slightly more detailed overview of the workshop program. Thanks.
Okay, thank you for coming. And so let's see, slide, please. Next presentation, please. Okay, so basically my goal is to expand, like kind of explain a bit more why you should care about dynamic algorithm and why this workshop will let you learn about all things about dynamic algorithms. So the first thing is about how dynamic algorithm can be used as a subroutine for fast static algorithms. And as Sayan told you, right, that one of the first application, actually like one of the first motivation to get dynamic algorithm is to get faster max flow. And this is by Slater and Tarjan 40 years ago. And actually, something like 10 years ago, it became even more clear that really trying to get fast dynamic algorithm in general graph and not just on trees, this is gonna give you faster flow algorithm. So this work by Madri really kind of make it clear in the community actually that once you have very fast dynamic shortest path algorithm, then something good is gonna happen. And after this 2010, like there are really continuous development on dynamic algorithm, and you see that like very recently, people do get fast max flow. And basically, the first tutorial of our workshop by Richard Peng, who is like a world expert in this area, will tell you about this for the whole 1 hour. And Aaron Sidford will give you some discussion about this direction as well. And then next thing is that there are many, actually, throughout these years, there are many graph algorithm techniques that is developed or transferred from other area to dynamic algorithm or developed inside dynamic algorithms. But it turns out that a bunch of these techniques turns out to be very powerful, and it just works across many other areas. So what I hope what I hope that you can get from this workshop is to learn all of these these techniques, and hope that even if you don't care about dynamic algorithm, it might be just still useful for you. And let me just try to go through it a bit. So the first thing is David Weiss is gonna talk about something called matching specifier. The idea about this is that if you have a graph which might be dense, can you find subgraph or like a small graph that still preserve the matching size in the big graph and dense? So that's the idea. And it turns out that this object is very useful in streaming algorithm, stochastic matching, and also in communication models. So I think like we hope to see more application from this, and David will talk about this. The next thing is the bigrammos. This is gonna be about vertex specification, and that idea is also about to compress graph. So you have a big graph. Now, can you compress it into like a into some graph with smaller number of nodes, such that this new graph still preserve some useful information, which can be anything. It can be about distance, it can be about effective resistance, it can be about flow. And the very cool thing is that if you can, and Gramos will talk about this, if you can have some fast algorithm for vertex specification, then there is some black box reduction that you can get some kind of dynamic algorithm for free. So this is like a kind of tight connection between two fields, and many of dynamic algorithm is obtained using these techniques. And the next thing that actually is going to be by me, I will also talk about expanders. So expander has been proved to be useful in so many areas, and in the last few years, it turns out to be proved to be very useful in dynamic algorithm too. And I hope to tell you why, how come is it so useful? What is the intuition behind it? What are the tools that allow us to use expander in dynamic graph? Even if the graph itself might not be an expander, how can you exploit expander anyway? And the techniques that is developed about expander from the dynamic algorithm actually turns out to be quite useful in the other areas, like distributed graph algorithm and just fast deterministic static algorithm too. Yeah. And okay, next is Eva Rothenberg. She's gonna talk about some techniques which is called lazy greedy. This is gonna be techniques that allows you to get dynamic algorithm with small recalls. And you will see in her talk that these techniques turns out to be kind of quite generic, and there is something nice about it. So this turns out to be useful for several problems, like edge orientation and planarity testing. By the way, this work is also it's very cool, and also there is some article in Quanta magazine. You can have a look in that magazine too. Right. And the next thing that I just want to mention, but although unfortunately we don't have time to talk about it, is some technique which is called greedy, randomized greedy. It's not going to be in this workshop, but if you have a look in the internet or YouTube, Sohail have a bunch of talks about this, and this also is a technique that is very useful for maximal independent set and maximal matching, this kind of problem. And it can be useful for many areas, like a dynamic algorithm, sublinear algorithm, MPC, and so on. So my point is, a bunch of techniques have been developed, and it should be useful across the area. And I think this is something that we want to hope for as an algorithm designer, right? We want some techniques that actually is robust against so many models of computation. and we did develop something like that. Yeah. And each of this talk is intended for a general audience. So it's going to be kind of tutorial style, not just specific to some work, just one paper. It's going to be about explain to you how this technique is developed and useful. Okay. Okay, good. In the last slides, most of the thing is about graph algorithms, but actually there are very cool techniques for other objects too. So first thing that will be in the workshop is by Jan. He will talk about dynamic matrix algorithms. So this dynamic matrix algorithm turns out to be, again, have a lot of application in graph too. And the application in graph is like the problem on reachability, shortest path, maximum matching, and so many things. But not on graph only. So it is useful for linear programming too. And as you might have seen that in the last few years, there are some very nice development in linear program, fast linear program solver. And in these last few years, actually, one of the main driving force is really trying to use dynamic algorithm inside linear program solver. And Jan is gonna explain how can you use dynamic algorithm as an application for linear program. So, and another object which is very interesting too is string. Just a string. And Thomas will talk about this. And actually, there are so many nice development on dynamic string in the last few years, and I'm quite excited to see this too. Okay. Good. The next thing that you will see in the workshop is kind of more of the high-level connection to other area. So there are more and more it turns out that in other area machine learning, there are some natural problems that can be phrased as a dynamic algorithm, and Omri is going to talk about this. The next and very interesting area is this differential privacy and cryptography. So so I really recommend you to have a look at this talk, which is in stock this year, and also this talk, which is already presented yesterday. So anyway, so it turns out that just this year, there is very new connection that is found from dynamic algorithm to differential privacy, and you can use it as a way to make the algorithm work against adaptive adversary, and this is one of the very interesting direction to look at, and but unfortunately in our workshop we will not have a long talk dedicated to this connection, but it's an exciting thing, so I recommend you to maybe go to this talk. And the next connection to other area is the area of fine-grained complexity. Amir will give some discussion in the panel about this, and there are this has been this connection has been found for several years already, and in this stock this year, there are exciting papers on this connection. You can have a look in these two talks, just in this talk, right? The last thing I want to mention is self-probe lower bound. This is about using communication complexity to prove some unconditional lower bound for dynamic graph, for dynamic algorithms. And you can, I recommend Casper talks, which actually we will put some link in the website too, but unfortunately we will not have time for, we will not have a slot for this too. All right, and today we will also discuss about some exciting future directions that we all think what should be the next big thing on dynamic algorithms. And this discussion there will be Amir, Sayan, Anupam, Varali, and Aaron that we will talk about this. So stay tuned until the later part of this workshop today. All right. By the way, because I will not be in the panel, I will just talk a bit to what I feel that is exciting, what I'm exciting about right now. So one of the things that I think is very interesting and still very less developed in dynamic algorithm is that just in dynamic graph, how can we construct some structure that is robust against update, which is not undirected edge. Okay, so there are so many, by now there are quite a bunch of algorithms that can handle edge update in undirected graph. But once you have a directed graph, then so many problems turns out to be very hard. And for some problem that we hope to have some good algorithm, it turns out that we just don't have enough tool for this yet. So just for example, the problem reachability problem, where you have a directed graph, and what you want to compute is just whether there is a directed path from S to T. This is very simple problem, and it turns out that the current state of the art is still kind of still not as satisfying as the state of the art in undirected graph at all. And I just want to mention that this exploration about what can be done in directed graph is very interesting actually. For example, if you can get something about dynamic arborescence algorithm, dynamic minimum weight arborescence algorithm, then if you make it fast, it's going to imply something which is very nice. For example, you can get near linear time algorithm for computing min cut in directed graph. And this is not known. The fastest algorithm right now, it was a kind of trivial algorithm that you just do n many max flows. And recently, we can make it square root n max flow. But if you actually have the fast dynamic algorithm for minimum weight arborescence, it can be made to this problem can be solved in linear time, near linear time, for example, right? And also, if you have fast algorithm for shortest path in directed graph, if it is fast enough, then you would get yet another exact max flow algorithm, which is almost linear time too, but it will not need to use interior point method, for example. So it's going to be to me, that is interesting. Yeah. Also, what if the graph is undirected, but you want to update a vertex? For example, you delete a vertex, or you turn off. You can turn off and on any vertex, something like this. Very few papers still is about this thing, about this vertex update, and I think there is a lot of direction regarding this to be explored. Okay, and that's the first direction I like. The second thing is general technique to make the algorithm, to make dynamic algorithm work against adaptive adversary. So I think throughout this workshop, like, you will actually know more about adaptive adversaries, but let me just tell you quickly. So in the dynamic algorithm, right, there gonna be some update that is given to you. Now, this update, if this update can depend on the output that you have output like in the last iteration or something like that, then you call that this adversary is adaptive. It turns out that for many problems in the state of the art, like in the state of the art of many problems in dynamic algorithms, if you assume that the adversary is oblivious, so not adaptive, then you can get very fast algorithm. But once the adversary is adaptive, the best known algorithm is very slow. Now, is there a way or some generic way to make an algorithm work against adaptive adversary? It turns out that, as I mentioned earlier, there is one kind of new generic techniques to make this possible, and that is to use differential privacy. And I really recommend you to have a look at that talk in STOC this year, right? But there should be more. The techniques that use differential privacy in that paper is really not fast. It's like it's not so fast yet. You need to pay some big factor in the update time, so it's not lossless reduction. Yeah. And one of the just two big concrete problem that I think would be super cool to have it solved. This is just a problem on maximum matching and maximum flow. So for both of these problems, actually, we know now that if you want exact, then there is some strong conditional lower bounds, and you cannot get anything that is faster than like a linear update time. But how about approximate version? This seems still very useful, but we don't really have very fast algorithm for these two problems at all. And it seems like a very nice goal. And I really believe that if you can solve it, there will be some new generic techniques that is developed along the way. Okay. All right. So basically, that's kind of the overview of the workshop for these three days. And by the way, if you want to learn more about beyond the talks in this workshop, please go visit this website, our workshop website. Sayan and I have tried to compile some nice material online, and you can have a look in this website. So there are many interesting talks and tutorial and survey. So go have a look. Right. Also, the last thing is that there's gonna be junior-senior meeting at the very end of this workshop. So if you go to the website, you can just sign up and put your name there too. All right. Okay, good. So that's it for my part. And next is gonna be a talk by Richard Peng. It's gonna be a tutorial on dynamic algorithm and optimization. So is Richard here? Okay, good. So good. So Richard is a world expert in this area, and I really it's my honor that he's gonna give a tutorial session for our workshop. So please welcome Richard.